And now we have from Germany, we're going to have Bernd-Alois Tenhagen from the Federal Institute for Risk Assessment.
You did a better job when you trained that.
Yeah. And he's going to merge two talks, so on MRSA in organic dairy herds and antimicrobial resistance in E. coli from our organic and conventional dairy herds in Germany.
Yeah, good morning, everybody. The reason I merged these two talks was that they're basically, the data stem from the same monitoring program, so I thought it might be not reasonable to talk about the monitoring program twice and repeat everything again and again. So I merged the two talks and now I have more time. That's very nice. Hopefully that will enable me to talk a bit slower than I usually do. So what I'm going to talk about is, first of all, resistant bacteria in raw milk, because that's what we tested. We tested bulk tank milk. Is it a One Health issue? Then I talk about the monitoring system in Germany, about the MRSA in the organic and conventional dairy herds, the E. coli, and then I'll sum up the results. So if we're talking about One Health, there's lots of complicated sheets that you can show for demonstrating One Health, but basically in terms of antimicrobial resistance, what we are talking about is that we do have a resistance issue in animals, and we just heard about that. We do have a resistance issue in humans, and we sort of have a common resistance issue, and we have overlap. So we have overlap, and we have, of course, bacteria moving from the animal side to the human side, and also vice versa. In terms of food safety, if we talk about milk, this is actually what we're talking about. We're talking about milk coming from potentially cows and going to people and children. And we have the animal husbandry as the origin of the bacteria, at least in the milk that is sold from the farm. But then, of course, we have here the step of pasteurization, so most of the bacteria will be killed. Nevertheless, we do have raw milk consumption in many countries, at least by groups of people. And then, of course, we have the issue of ingestion and contact to this food. And once the bacteria have reached humans, they may also be exchanged between humans because we live closely together with humans and only with pets, most of us. The other issue that we have is, of course, the occupational disease issue, and Theo Lam talked about that. People go into hospital working in animal farming or animal practice, and that are just shading the red light when they enter the hospital situation. So we do have animal husbandry. We do sometimes have very intensive contact with these animals, not only with pets, but also with farm animals. And of course, these bacteria on this way may come to humans, and we know that this is very important for example, MRSA, but it may also be important for E. coli, because sometimes E. coli occurs in this area of the animal. So point one, antimicrobial resistance, and I abbreviate that with AMR all the time. Antimicrobial resistance in dairy cattle is relevant beyond the therapeutic efficiency in farm animal practice. Now, what do we do if we treat an animal with antimicrobials? And that's why I asked for this systemic treatment that David talked about. Basically, what we aim to do is kill the pathogen. And that's what we're going for. So we do a proper diagnosis, we do select the right antimicrobial, we do the right dosage over the right period of time, and you see all these red dots have black crosses, so we did a successful job here. What we did at the same time, of course, was treat the gut flora, because most of these antimicrobials either are given orally, that applies mostly to pigs and poultry, but also to calves, and enters the gut, and we do have quite a number of bacteria in there that are not at all related to our disease issue. And they are all treated, and we don't know the minimum inhibitory concentration. I'll talk about MIC later, that's easier. And so we don't know if it's over or underdose for these bacteria. It doesn't really matter. We do treat the skin flora in some way or the other, especially if we do feed antimicrobials. And of course, most of these antimicrobials will be shed to the environment. And so we do treat antimicrobial environmental bacteria with antimicrobials as well. And all these bacteria have benefits from becoming resistant. And they are far, far more than those that we aim to treat. It may be a bit different if we're talking about intramammary treatment, because in intramammary treatment, most of the drug will remain in the mammary gland, And so the issue of treating the whole gut flora may be less relevant in that case, and also the shedding into the environment may be less relevant. On the other hand, at least if we do use waste milk, in some way or the other, these antimicrobials may end up in the calves and may obviously help in producing the numbers that were just shown in the last presentation. How often do we do that? And actually, Theo already referred to that. So if we talk about dairy cows and numbers of treatment per 100 cow days, we see that dairy cows are, well, infrequently treated compared to other animal species that we raise for sort of food production. Especially if we're talking about veal calves, we're talking about turkeys and broilers and poultry, talking about piglets and weaners and fattening pigs. So they're all treated far more often than the dairy cows. And what are we using? I think this is the actually problematic issue about it, and that has been mentioned several times before. We're using quite a number of these antimicrobials that are characterized as critically important antimicrobials or prioritized critically important antimicrobials, such as cephalosporins here in red and fluoroquinolones here in black. So these are a large proportion of the treatments that we do in dairy cows. And this is, of course, an issue in terms of One Health, because these antimicrobials are especially relevant for humans as well. So conclusion number 2, antimicrobial use in dairy cattle is fairly low compared at least to other animal species or other types of animal production, we should say. The share of problematic antimicrobials is fairly high, and therefore antimicrobial resistance in cattle definitely needs to be monitored, and that's what we did. That's what I come to now. So we have set up a monitoring system in Germany in 2009, actually, where we try to monitor all the major food chains from the farm side through the animals down to the food. So it would be table, eggs, and laying hens, or highlighted here, dairy cows and milk, because that's what I'm talking about today. And we try to do these food chains every 2 to 3 years, sometimes 4 years. So we're not doing every program every year, but rather focusing on specific programs per year and then repeat them in a 2 or 3 year interval. And within that monitoring protocol in 2014, we decided to do monitoring separately in conventional dairy herds and in organic dairy herds. We had done such a monitoring program in dairy herds before, in 2009, 2010. And actually, anytime we presented the results, people would ask, well, how's that in organic farming? So as organic farming is only a small part of dairy production in Germany, in our sampling frame in the first years when we did that, the portion of the organic farms is very low. So we decided we'd do an extra sampling frame this time for the organic dairy herds, so we get more samples from the organic dairy herds, so we have something we really can talk about, can compare data about. And this was done as well for MRSA as also for the E. coli that I present later. So we distributed the samples across Germany to the different federal states according to the animal population. So the federal state with the most of the cows, that would be Bavaria in Germany, they would have to take most of the samples. And for the resistance testing, we used broth microdilution according to CLSI guidelines. And we evaluated the MICs that we determined by the UCAST epidemiological cutoffs. So nothing very specific here. Organic farming in Europe, as you know, is regulated in a regulation by the EC, and so it's defining the organic farming and also organic animals. And of course, there's regulations concerning antimicrobial use that are tighter than what we have as regulations on antimicrobial use in non-organic animals. And at least in Germany, there's a lot of organic associations that have their extra rules, and most of the times these extra rules are more strict than the EC rules. Obviously, they're not allowed to be less strict. And if you look at the development of organic farming in Germany, this is just organic farming in general. It's not on dairy cows specifically. You see that the number of hectares that is worked on in an organic manner has increased substantially in the last 20 years, so it has more than doubled, and it is an ever-increasing process. And as milk prices in organic farms are fairly high now, and milk prices in conventional farming are, well, not really prices, there is a tendency to go for organic farming. what has been monitored, it was bulk tank milk samples in dairy herds. So the sampling people went there, took the samples from the bulk tank. And it has been tested for a number of bacteria that I'm not going to talk about, and for E. coli as an indicator organism for antimicrobial resistance, so not as a pathogen, and MRSA that I'm going to talk about first. So why am I going to talk about MRSA? We have heard some things about MRSA shortly by Theo already. Actually, we have two issues in MRSA. You see this, again, these two bubble graph just at the very beginning, the One Health graph. And we do have a lot of MRSA in humans in Germany. And this is what you always find in the newspaper, people dying from infections, and everything is very bad and very serious. And since roughly 10 years, we do have detected livestock as associated MRSA in the German animal population, basically in all types of animal population. And usually, apart from cattle, actually, it's not associated with animal disease. So the pigs carrying these MRSA are perfectly healthy. And it's predominantly one type of MRSA, that is the clonal complex 398. It's just a genetic marker that identifies this type, and it's different from the types that you see in human medicine. The share actually is mainly in MRSA in farmers and vets, because they are mostly carrying this animal-related type and not carrying the human-related type. But this is only, in total, it is 2 to 5% of the MRSA that we see in human medicine are of this animal type. In cattle, you know Staph aureus, well, I don't have to tell you, it's a mastitis pathogen, so there is limited treatment success anyway, and now we have MRSA, and it's not getting better by that. It was detected in bulk tank milk already in 2009, 2010. As I said before, we did a program in that years, and it was 4 to 5% of the samples were positive in that year. And farm stuff was also colonized in regional studies with the same strains that you find in the milk and in the cattle, not surprisingly. You do have a high detection rate in veal calves that I'm not going to talk about today. And there's reports on associations with regional livestock density, especially from Italy. There's a nice report showing that pig density in the region was a risk factor for the dairy farms to be positive for MRSA. So, very simple results slide. These are the data from 2009 and 2010, so 4 to 5%. And now this is the data from 2014, 4 years later, and it's actually doubled. It's 9.7, I think it was, percent of the samples were positive. So 1 in 10 herds was positive for MRSA in the bulk tank milk. And it's substantially lower in the organic farms. That was only 1 point something. We do see that we have an increase compared to 5 years ago. So not everything is getting better. And of course, this is an upcoming risk because the regional labs also report that they do get more isolates from mastitis cases with resistance to these antimicrobials. If we look at the SPA type, well, the SPA types actually are a different way to categorize MRSA. So they are a bit more finer, grading them up. And all the blue stain that you see here is basically the CC398 stuff. So you see most of the isolates, 4 or 5 in the organic farms, and actually it's, I think, 34 or 36 were from this CC398, this typical animal-related type. And there were 3 other ones. One actually that's cow-related usually, that's the T127, and then there's one that's poultry-related usually, that's T1430, and there's one that's actually human-related, that's T790. This is a bit of an odd graph. Usually these graphs start with a green bar on the left side because there are susceptible isolates, but in MRSA by definition we don't have these susceptible isolates, and every new color represents an additional antimicrobial resistance towards a different antimicrobial. And as you can see here, the number of different antimicrobials is higher in the conventional herds, not surprisingly, than in the organic herds. If we go down to the individual substances, I'm not going to go through all of these substances, and I want to remind you that we only had 5 isolates of organic herds, so actually comparing the length of the bars is probably not really relevant. What I like to point out is we do, of course, have resistance to penicillin and cephalosporins. We do have resistance against tetracyclines. Actually, the 3 isolates that were not resistant to tetracycline were the non-CC398 strains. And we only have very limited resistance to the drugs of choice in human medicine, vancomycin and fusidic acid, etc. So conclusion number 3, nearly 10% of the conventional dairy herds harbor MRSA, and several other resistance traits besides beta-lactams are carried by these isolates. and the prevalence is low in organic farms. Problem, as I already said, exposure of staph in the farm's family, potential mastitis problems, and relevance for food if food is consumed raw. Oops. So, coming to E. coli, we had the same sampling frame as before. Again, broth microdilution, different panel of antimicrobials because it's a gram-negative bacterium, and the same evaluation criteria. The prevalence was for us not relevant, so we didn't actually calculate prevalence. And this is just to put it in perspective. These are the resistance data from all the programs that we did in 2014. And as you can see, the green part of the bar are the fully susceptible isolates, and every new color is an additional antimicrobial resistance. And you see in the dairy herds, we hardly have any resistant bacteria compared to poultry production where we hardly have any susceptible bacteria. And if we look at the individual substances, we see that the number of the proportion of resistant isolates to the individual substances is very low. It's basically to sulfamethoxazole, tetracycline, and another acid here. And there's only one resistance to ceftazidime. And well, you can't compare it between organic and conventional on the individual basis. But if you look at the number of resistances, sorry, I have to go back. If you look at the number of resistance, you see that it is even, the number of susceptible strains is even higher in the organic herds. So it was 95% compared to 90% susceptible strains. Comparing it in the long run, so over the years, comparing it to data of 2009 and 2010, this is only the conventional herds that I put in here because the other sampling frame was different. And what you can see is this is the number of susceptible strains that it actually increased compared to 2009 and 2010, but only slightly. So in conclusion number 4, AMR is not a major issue in E. coli from bulk tank milk in Germany. In organic farms, the problem is even less severe. And in conventional herds, AMR tends to decrease over the years in Germany as well. So this is, things are sometimes growing. These are actually the same involved people here. Both is my daughter and both is my, well, now it's a cow, then it used to be a heifer. I have to thank all the local and regional services and the regional labs who did most of the work. I have to thank the BVL for collecting data and the laboratory staff, especially at BFR, and also my co-authors that I acknowledged on the first slide. And I thank you for your attention, and I'll be happy to answer questions. And I have plenty of time. And you have plenty of time to ask.
Yes. So we'll take questions from the floor. From Germany. Can you just get the microphone first, please, and then...
Yes, thank you for your very interesting data. Could you correlate your data with the connection to pig housing in these milk, in these dairies?
No, we didn't have any information. That is a bit a problem of these monitoring data that you have in the national monitoring system. Usually the amount of data that you get per sample is limited. So sometimes you do have the farm size, you do have the location of the farm, but it is very scattered, actually. If you see the positive herds, it's not that you say it's one region where you have most of the animals. So actually the positive herds were scattered across the Republic.
Unfortunately, it was the same question. If you had any data about the situation of the farm, the presence of pigs, for example, any data like that, because in Italy, for example, we found a very important correlation in dairy cow with pigs, the presence of pigs for MRSA. So that was the question, but I understood that you didn't have the data of risk factor for the farm. That's correct?
Yeah, we didn't have the data for this study. I know that also in Germany, in the southern part of Germany, they have done investigations in where do we find the MRSA positive herds. And they also found a correlation to districts where they had a lot of pigs and also a lot of poultry in the region. So they found more of these herds there. But of course, in many instances where you have these pigs and poultry, you also have the dairy cows. And then you sort of get mixed up if you only see it there because there are so many dairy cows, or if you see it there because there are so many pigs. So sometimes it's difficult, but the Italian data for me also were quite convincing when I read them in the paper.
Hi. Did you do much knowledge transfer with the farmers that had resistance? And are farmers told whether they're at risk if they go into hospitals, having more likelihood of being harbouring resistant bacteria?
Actually, we do that. We don't specifically do it for the dairy farmers. It's done for all types of farmers. And from the studies in human medicine, we know that the risk of harboring MRSA yourself is much higher for the pig farmers than it is for the cattle farmers, because among the fattening pig farms, 60 to 80% are positive for MRSA. So these farmers most likely will harbor MRSA. Whereas if you have 10% positive dairy herds, of course, in dairy farms, the problem is still less severe. I think the major issue that we have here is that it is a mastitis pathogen, that we know that it tends to be very robust against our efforts to eradicate it from a herd.
Hi, Ed Bailey from the UK. I was just intrigued by one of your last slides. It indicated that the proportion of resistant E. coli on fresh herbs looked like it was higher than in dairy cows. And it sort of tied in with something that I found on an organic farm that I go to, where soil samples indicated resistance to antibiotics that had never been used on the farm. And I just wondered how you felt we could tease out the problems of resistance associated with antimicrobial usage versus naturally occurring resistance in environmental bacteria.
Well, first thing you have to say about it, well, it's not the topic actually today, but the fresh herbs, is they didn't have to be from organic farming or from the national production, and so you don't really know the origin of these E. coli that we find in there. That was a study that was actually done to measure the exposure of the consumer if he buys this stuff and eats it raw. And so it's a bit difficult to say, well, it has never been used there, and how did the bacteria get there? All in all, as you see here, we only had 15 isolates there, so you should be very careful in evaluating the prevalence here. And also, what is important, I think, that these 15 isolates, they stem from 380 samples. So the prevalence actually of E. coli on these herbs was fairly low. And among these E. coli that you find there, then a couple of them are resistant. And actually, I think there were even 2 ESBLs among them. So you do see these bacteria, and of course, we do have an environmental issue, but it's very difficult to get a grip on that. For example, if you look at wild animals and the resistance situation in wild animals, that usually is much lower than what you see, for example, in pig or poultry farming. Although, even if you shoot the animals in the area where the pig and poultry farming is situated. So the direct exposure, I think, is still the main driver for the AMR and the bacteria.
The chairman is allowed to ask one question. And I'd like to ask maybe some of the other panel as well to think about this. But how did you manage the risk communication around to the public around issues like the AMR and the food chain? So, you know, that's something that in Ireland we struggle with, that if you have a significant issue and the general public, how do you present this data to them? Or is it something, how do you manage that from a risk communication point of view?
Well, first of all, these data are presented in yearly reports, similar as the report of Moran that Theo has cited. And of course, we also include an evaluation of this situation. Of course, if we find results like we find in poultry, we say there is, of course, a health risk associated with the consumption of poultry meat if you consume it raw. Well, usually you wouldn't consume it raw, but we talk a lot about responsible use of poultry in the kitchen, let's say. That you have issues of cross-contamination to other food items that you will not properly heat, and then you have a higher risk from that. But for poultry meat, actually, that's nothing new, because we have a lot of Campylobacter, and we used to have a lot of Salmonella on the poultry. So people are already aware that dealing with poultry meat is an issue, and that you have to be more careful than if you talk about pig meat or cattle meat, actually. So the reaction, actually, on these reports usually is not very excited. Okay. Sometimes I even think we're a bit ignored. I don't know why. And then if some NGO tests two samples and publishes that, then there's a lot of trouble in the mail and the press. And only if we then say, well, we did that last 5 years and we have tested 1,000 samples, and that's real numbers here, then and we are aware of that, and we are taking measures, or they are actually reducing a lot of antimicrobials. I didn't talk about reduction of antimicrobials in animal farming in Germany. And we see that also in poultry, although these figures look awful, they're going down, the proportion of resistance strains.
So I'd like to ask any of the other speakers, or Theo, have you any thoughts on this? I mean, you were communicating your mindset model was changing behavior, but you had to benchmark that and show how bad things were. So were there any issues over public interpretation of data, even at the beginning?
Well, as Bernd says, there are basically two different things here. One is how to communicate the potential risks and the issues on the industry as a whole, and the other thing is what people should do with their food consumption, with their safety on treating food, etc. The latter is not a thing that's very sexy, because people should have known it and they should have learned it from their mother or from their father or in school or whatever. And if we bring out that kind of things, that doesn't hit the headlines. And that is because it's good news. It's nothing new there. And if some NGO comes out with some drama, with some major whatever thing based on nothing, that's news, because the press is interested in news. And news is bad news, something that can make politicians fall over or that can make whatever industries fall over. So there's a big difference there. And if you really want to go back to the food safety thing, what you need to do there is approach it, well, according to the reset model or other models, in which you use, if you really want to change behavior, only a small part of it is knowledge. Only a small part of it is for those people that are, as I explained, internally motivated. They want to know it's because this or that temperature for that long, etc., etc. And if you really want to change behavior on that type of things, you need to use indirect ways too. That's a different pathway than the pathway on how do we handle this as an industry. And in that sense, that's very difficult. And if there's not a problem, according to the general public, it will be very, very hard to get that message across through communication. And if there is a problem, you don't have to do it yourself. People will do it for you. What we did in the other health approach was that we used an award. It was not our idea, it came from the NMC, an award for best other health. And that was a way that you could do it. And sometimes we were able to get the national news on, okay, good other health and great this and then that. And then at some point come people up, why do you need all this extra attention? So from the industry part of it, it's no news is good news. And from the food safety part, well, as I said, you need to use different approaches, of which education definitely is one, but not the only one.
Thank you. So any final question then for Bernard? Just one final one, yes?
We're discussing of banning cephalosporins for animal or veterinary use. You said their use very, very common in dairies for 20 years now. So how do you think, or do you think it's worth banning them to reduce the MRSA or ESBL in dairies?
I think, I don't know, was it David or was it you? One person already said that it doesn't go for banning the substance, but rather go for don't use it. So you don't have to ban it for not using it. And I think we definitely have to reduce the use of cephalosporins and fluoroquinolones in dairy practice. Because what we're talking about here was only the situation in the dairy cows. What we are not talking about is the situation in the calves. And I think that Anna just showed the data on the situation in calves, and what we consistently see is that the resistance situation in calves is much higher. And if you look at which type of animals do you find ESBLs most frequently, then it is actually in the calves. More frequent than in chicken, more frequent than in pigs or whatever. So definitely for the cephalosporins we do have an issue, and we, as most of you may know, there's a working group installed at EFSA dealing with the issue of feeding calves with waste milk. So does that work? How does it work? Which consequences do we have on antimicrobial resistance? And there's studies from the UK, for example, showing that if you feed waste milk to calves, that you have a much longer carriage of the ESBLs by the calves than if you do not do that. So there's a lot of issues beside the bulk tank that we have to consider that I didn't talk about today.
Okay, can I thank very much Bernard for his very interesting presentation and interaction of the speakers and with the questions. It's very, very informative to us all. Thank you very much, Bernard.